Okay, so let's talk about Newton's law of cooling. So according to Newton, he discovered that the rate in cooling, the rate that an object loses its heat, is proportional to the difference between the temperature of the object and the temperature of its surroundings. So in other words, so if we take the rate, right, T prime, then we know that this is going to be proportional to the difference between the temperature of the object minus the temperature of its surroundings. So let T represent the temperature of the object, and let T sub A in this case be the temperature of the surroundings. And so this is the rate of cooling. So this is what Newton had determined. Okay? Now, if you look at it, it's not quite the model we want to use for exponential decay, but notice that it's a differential equation very similar to this one. Okay, so look. Y prime equals negative k y0 e to the negative kt. Where, what did we do? We just did that, right? So it looks very similar, but it's not quite right. Okay? So we want the derivative to be proportional to the function. And this expression has the additional term, the T sub A term, right? So what we can do is we can change some things around. Okay, so we're going to change some variables to resolve the issue that we have here. So let's do this. Let's make this into another variable. In fact, let's make it a function of time. Right? Because the temperature of the object, right, changes over time. So make this y sub t. So now, we're assuming that the surroundings pretty much stay constant, okay? So that means y prime, in this case, is going to be t prime of t. And then of course this goes to 0, right? And so we could just get rid of that. Okay? So, now, by making these changes, now it fits. Right? And so now what we can do is we can go ahead and look at what we did before, at our previous work. And so we know the relationship between these two gives us this, right? So we know this gives us the function that y equals y naught e to the negative k t. So now, how would that affect what I have here with my substitutions? Well, what is it going to look like? So I've got this. So this is going to end up being what? T of t, or excuse me, I'm sorry. Y of t right? So this will be y of t equals y naught e to the negative kt. Now, watch what happens. So let's now substitute in what we have here. So y of t, that's just going to be t of t minus t of a, okay, equals, now what do we do with this? Y naught. Well, that's just going to be the initial values here, right? So it's going to be the same form, right? But instead of, this is going to be t0, y0, t0. So this is just going to be equal to t naught minus t sub a, right? E to the negative kt. So far, so good? And then, of course, I want it in terms of t, so I'm just going to add t sub a to both sides, and I get my final equation is equal to that. And that's what we're going to use as our function. And so now let's apply this formula to an example. We'll do that next time.